All right, guys, question number 4. And once again, number 4 should be a video that you watch before you watch video number 3. Although I did record number 3 before I recorded number 4. Anyways, write the following in simplified form. We have the 4th root of y to the 13th power. Assume that the variable represents positive real numbers. Okay, for us to simplify this, we want to convert our radical into a rational exponent. And how do you know when to do this? Well, I'm going to write it down here. When the radicand of the radical is a variable, convert the radical to a rational exponent. Excuse my handwriting. When the radicand of the radical is a variable, convert the radical to a rational exponent using this conversion rule. So we're going to do that. The radicand of my radical is y. In this case, y to the 13th. But I'm going to say y. And this here is my a. The power is going to be my m, and that's going to be 13 in this case. The root is my n, and my n is 4. So we'll transform that to y raised to the 13 over 4 power, 13/4 power. And we try to simplify from there. Well, 13 divided by 4 is a decimal, 3.25. And we do not want to have a decimal as our exponent. So what we're going to do is we're going to do long division. We're going to take our 13 over 4 and apply long division. When I do long division, I'm doing it on the right side. The numerator goes inside my long division symbol, while the denominator goes on the outside of my long division symbol. Now we ask ourselves, how many complete times can 4 go on to 13? 4 can go on to 13 a total of 3 times. 4, 8, 12. 3 times. 4 times 3 is 12. Place that product below the 13 and then subtract. 13 minus 12 is 1. The number on the top represents your quotient. And the quotient represents the number of powers of the variable that exits the radical. I'll write it down. Number of powers of the variable outside the radical. The number on the bottom, which is just 1, that is known as the remainder. Write that better. And the remainder represents the number, the number of powers of the radical, of the variable that is inside, or that is under the radical. So in this case, 4 powers of y will exit my radical. My apologies. 3 powers of y will exit my radical, while 1 power of y will remain under my radical. And please do not forget the root. This is a 4th root. The original root here was 4. Therefore, it must stay the same when I write my new radical. And that is the answer to number 4. All right, guys, that is it. Hope you guys enjoyed it. Hope it made sense. Once again, this is used for question number 3. So please watch this video to get more in depth of this process. All right, guys, I'll see you soon.